In lesson 19, we're going to continue with writing expressions that represent real-world situations. And with these, we're actually going to be looking at tables and using tables to determine what those expressions would be. So if you see below, it says, my older sister is exactly 2 years older than I am. Sharing her birthday is both fun and annoying. Every year on her birthday, we have a party, which is fun, but she always brags that she is 2 years older, which is annoying. Shown below is a table of her ages, starting when I was born. So when she was born, she was 0 years old, her sister was 2. When she was 1, her sister was 3, and so on. So looking at the table, what patterns do you see? It says tell a partner. We're not going to do that part. So the pattern that I see, well, 0 plus 2 gives me 2. 1 plus 2 gives me 3. 2 plus 2 gives me 4. 3 plus 2 gives me 5. And 4 plus 2 gives me 6. So the pattern I see is that if I add 2 to the younger one's age, I get the age of her sister. So on the day I turned 8, how old would her sister be? So that would be 8 plus 2. So her sister would be 10. And how do I know her sister is always 2 years older? On the day she turned 16, how old would her sister be? And you just take 16 plus 2. And so her sister would be 18. So when she is 16, her sister is 18. How do I know? Her sister is 2 years older. And do we need to extend the table to calculate these answers? No. Because the pattern is the younger one, the younger age plus 2. So we don't need to keep doing the table because all we found based off of the table that we just have to add 2 and then you'll find the older one's age. So that's what we're doing. We're looking for the patterns that are on those tables. So here's our next table. It's her age and her sister's age. It's that same thing, but we can finish the table, so it's still the same pattern. We're still adding 2 all the way through. And if we're going up by 1, so what if you don't know how old she is? Let's use a variable for her age. It says let y represent her age in years. So this is y. And we're just going to do the same thing here, but if we take y plus 2, we don't really get an answer. So what we're going to put is just y plus 2. And so this is the expression that represents her sister's age. And this is the variable that represents her age. So if you don't know, let's use the variable for y. Can you develop an expression to describe how old her sister is? And her sister is however old she is, plus 2. And then please add that to the last row, and this is how you would add it to the last row. So we're going to do the same thing for this next one. But it's going to be the opposite, which is what we talked about yesterday, about how if her sister is 2 years older, then she is 2 years younger than her sister. So if we're going to go from this side to this side, we then have to take the number, move it, and find the opposite. And we'll show how that works. So down here again, it's the same pattern, plus 2, plus 2, plus 2, plus 2. How old was I when my sister was 6? So you look here, her sister, when she was 6, she was 4. So she was 4 years old. How old was I when her sister was 15? Well, if we look here, the pattern is that you subtract 2 from her sister's age, and that's how you get her age. And so you take 15 minus 2, gives you 13. So she was 13 years old when her sister was 15. And how do you know? The younger sister is 2 years younger. which is subtracting 2. And so you just look at what it's asking and then find the pattern in the direction that they want it in. So it says, look at the table in example 2. If you know my sister's age, can you determine my age? Yes. I subtract 2 from your sister's age. If we use the variable g for her sister's age, what expression would describe my age in years? So remember, we had her sister minus 2 will give us her age. And then if we put that in the last row on this page, her sister, they said, was g. And so her age would be whatever her sister's was minus 2. And then using the expression, we can calculate these things. So if her sister was 22, you'd take 22 minus 2, and her sister, the younger sister, would be 20. And then you could take 23 minus 2, and the younger sister would be 21. And then if you take 24 minus 2, the younger sister would be 22. And again, all we're doing is taking the age of her sister and plugging it in for the older sister's age and then subtracting it. Let's take a look at the exercises. It says that Noah and Carter are collecting box tops for their school. They each bring in 1 box top per day starting on the first day of school. However, Carter had a head start because his aunt sent him 15 box tops before school began. Noah's grandma saved 10 box tops, and Noah added those on his first day. Fill in the missing values that indicate the total number of box tops each boy brought to school. So this is what they had on the first day of school. They had what was sent to them plus 1, because they also are bringing 1 a day. And if they're each bringing 1 a day, that means we go from 11 to 12, and then the next day he brings another one, and then another one, and then another one. And then for Carter, he had 16. When he brings 1, he brings another one, which makes it 17. For Carter, he had 16. He brought another one, he'd have 17. And he brought another one, he'd have 18, and then 19, and then 20. So every day, they brought 1. Now it says, if we let D be the number of days since the new school year began, so this is D, number of days, how many box tops will Noah have brought to school? So what we have to look at is the relationship between these two boxes. So I have a 1 and 11, a 2 and 12, then a 3 and 13, 4 and 14, and 5 and 15. So I need to know what am I doing to D, or my number of days, to get these numbers. And the difference every time is 10. And so what it is days plus 10 is how many box tops Noah has. So that's the expression for how many box tops Noah has. Now down here it says on day D of school, how many box tops will Carter have? So now I need to go to Carter's side. I'm going from a 1 to a 16, a 2 to a 17, a 3 to an 18, a 4 to a 19, and 5 to 20. And so I'm actually adding 15. So 15 plus 1 gives me 16. 15 plus 2 is 17. 15 plus 3 is 18. 15 plus 4 is 19, and so on. And so for Carter, I take my day plus 15 is the expression for how many box tops Carter brought to school. So then it asks us, on day 10, how many box tops will Noah have brought to school? So I go to Noah's equation. So this is Noah's equation right here, D plus 10. So Noah's is D plus 10, Carter is D plus 15, so my number of days. And then it tells me that the number of days is 10. And so what I'm going to do is I'm going to take my 10 and I'm going to plug it in for D. And so what that is 10 plus 10, that gives me 20. So Noah brought 20 box tops on, not brought, has. So we should have all of these be has. Noah has 20 box tops on day 10. And then it says on day 10, what about Carter? Well, Carter's expression is D plus 15. And we're on day 10, so we add 15 to 10. And Carter has 25 box tops on day 10. And so that's how you would end up solving it. So let's take a look at number 2 as another example. Each week, the primary school recycles 200 pounds of paper. The intermediate school also recycles the same amount but had another 300 pounds left over from summer. The intermediate school custodian added the extra 300 to the first recycling week. So we have week 1, and it says the primary schools each recycled 200 pounds of paper. And so this is my primary school, so I'm going to have 200 pounds. And then the intermediate school had 200 pounds plus 300 pounds from the summer. And so they had 500 pounds of paper. Now, number the weeks and record them. So every week, it says each week they had 200 pounds of paper. The intermediate recycles the same. So they're also going to be doing 200 pounds a week. So on week 2, we would have 400. Week 3, they would have 600. Week 4, they would have 800. And on week 5, there would be 1,000 pounds of paper. For the intermediate, they're also going up 200 each week. So that would then be 700, 900, 1,100, and 1,300. So if the trend continues, what will be the total collected for each school on week 10? They're wanting to know in terms of week 10. So that means I need a W in each of my expressions. So I look at my 1 and I get 200. 2, I get 400. 3, I get 600. 4, I get 800. 5, I get 1,000. If I'm looking, 1 plus 199 is 200. 2 plus 199 would be 201. That's not what's happening. So I need to look at division or multiplication. So 1 times 200 is 200. 2 times 200 is 400. So we have a multiplication happening. So we have, for this one, we have 200 times W is how much the primary schools did. But over here, if I take 1 times 200, I got 500. But that's not true. 1 times 200 is 200. So I can try 1 times 500. Then if I did 2 times 500, I would have 1,000, but I have 700. So that means you need to look at what happened here. What this really was is that we had the 200 per week plus the 300 from the summer. So that there was from our summer. But then this is per week. So this 200 is changing with this, but this 300 doesn't ever happen again. So our expression is actually 300 plus our 200 a week. So we take 200 times whatever week it is, and then we just add on that 300 that we had from the summer. So this is your expression for the intermediate school. So if it continues, what will be the total amount collected? Well, we would show for our primary, you have 200 times what week 10? So they would have 2,000 pounds of paper. And then for the intermediate, you have a 300 plus 200 times 10, which is 300 plus 2,000, which is 2,300. So they had 2,300 pounds of paper recycled. No, you're going to need to do number 3 on your own, or number 2 on your own. I'm going to do number 3 for you because I want to talk through what it's asking you. So a train consists of 3 types of cars: boxcars, an engine, and a caboose. The relationship among the types of cars is demonstrated in the table below. So this is a finished table. Tom wrote an expression for the relationship as B plus 2. So it's boxcars plus 2. Let's check his. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. 10 plus 2, 100 plus 2. So Tom's expression is correct. Let's look what Teresa did. Teresa wrote an expression for the same relationship as C minus 2. So we look at the number of cars. And so 2 minus 2 is 3 minus 2 is 1. 4 minus 2 is 2. 12 minus 2 is 10. And 102 minus 2 is 100. And so is it possible to have 2 different expressions represent one relationship? The answer is yes. It changes depending on which variable you use in the expression. So depending on the variable you decide to use, your answer can be different. But it still is the same relationship. Tom was talking if we went from here to here, and Teresa was talking about if we started here and needed to go there. So what do you think the variable in each student's expression represents? How would you define them? And so B represents the number of boxcars, and C represents the number of cars in the train. And we knew that because looking at the relationship, you could see that it was true. What I'd like you to do is complete number 2. I want you to complete number 5 at the bottom and number 6. This is the table I'd like you to use to be able to answer A, B, and C. Please make sure that you have an answer for each of these on your paper. So that's 3 parts. You have a table and 3 questions that you need to answer. You can work with a partner on this if you choose to whisper. If you decide to be louder than a whisper, you will be asked to work alone.